Okay, welcome back to our discussion on building APIs with Go. So in this lesson, I want us to look at a bad request and how to handle requests from the client that are malformed. What do I mean by that? Well, let's look at an example. So let me start up the server. And let's issue a few client requests. So I have a couple already. Let's say I do curl, but instead of a JSON, I use XML. That's a bad request. And so we get back error, invalid character, looking for a beginning of value. Now, obviously, this isn't really client friendly. So we would want to issue a kind of more client friendly error message. What about this one? We have a list instead of curly braces. Okay, and what would happen if we send that as the request? So we get back all of this. Now notice that the error message actually exposes the name of the fields that we are using for our struct. So again, this is not something you'd want to do. You don't want your internals to be exposed. And secondly, this is just not a very good error message. The client will not really understand what they did wrong. What about this one? We use the wrong type, okay, for the value. Okay, so JSON cannot unmarshal number into Go struct field dot name. Okay. And what would happen if we did not provide a body? Okay, an empty body. All right, error EOF. Okay, so what we want to do is to create a sort of better, more human readable errors for each of these malformed client requests. So that's the task. All right, let's get to it. So what I want to do, currently we have our decoding happening in the handler. So I want to move this and I want to place it in its own method. Okay, so let's go to helpers, and inside the helpers we will create a helper that allows us to decode our JSON request. Okay, so let's go ahead and do that. Okay, so it's a method on application. It's going to be named readJSON, and it will take the response writer, the request object, and it will take a destination variable, which basically is where we will be storing the decoded values. Okay, now if there's an error, we want to return an error. Okay, so remember, DST will be a pointer, okay, because that's where we will be in other words, DST represents our struct. So if we go back here, DST would represent where we're going to store the decoded values. Okay. Great. So once we have that, then we can proceed to actually do our decoding. So the first thing we want to do is to decode the request body, okay, into the target destination, right? DST. So let's go ahead and do that. We know that JSON provides us with a new decoder function method, and it expects something that implements IO reader, and so we know that the body does that, and it will return a pointer to a JSON.decoder. Now once we have that pointer to the JSON.decoder, we can call it decode function on that JSON.decoder object and pass in where the value should be stored, which is a pointer. And so we know DST is that pointer, and so we are okay. So easy enough, but the biggest issue is there can be errors during the decoding process. And so, like I showed you earlier, we have quite a few scenarios where the request is malformed. It's a bad request. So let's check for a bad request. Okay, so this will be a bit involved. So if error not nil, then we need to sort of check for different types of errors. We have syntax error. You have unexpected end of file errors. So those occur when we have a syntax problem with the JSON. Okay. We have an unmarshalled type error where whatever the user is sending, the client is sending, doesn't match up with the type in our struct. All right. And of course, we could have an empty struct, which would be an end of file error. So let's check for these possibilities. So let's start off by creating a variable named syntax error. Okay, so this variable will be of type JSON that syntax error. Okay, so syntax error is one type of error that can occur. Okay, when we have a syntax problem with the JSON that we're trying to decode. Another type of error that occurs when we have a syntax problem with the JSON we're trying to decode is an unexpected end of file error. Okay, so keep that in mind. Now another type of error is I'm going to use Unmarshalled type error. Okay, and this variable Unmarshalled type error is of type JSON that unmarshalled type error. So this type of error occurs when there's a mismatch between what we are expecting in our struct and what the user actually provides in terms of the type of the value. Okay. Now, there is also another error that can occur. And by the way, this is all in the JSON documentation. Okay. So we have an invalid unmarshalled error. Okay, so what exactly is an invalid unmarshalled error? Well, this type of error occurs when something or what we're trying to use as destination is not a pointer. So in other words, the programmer screwed up and they did not provide a pointer to the struct where we can store the decoded values. Okay, and that is an invalid unmarshalled error. Right? So an invalid unmarshalled error describes an invalid argument passed to unmarshalled. Right? So the argument to unmarshalled must be a non-nil pointer, and we've discussed that in a previous video. All right, so this is where the programmer screwed up. All right, so what I'm going to do now, I'm going to switch to check for the errors. Okay, so I'm just going to make a switch statement. Okay, and so let's check for syntax error. Okay, so let's check for syntax errors. All right, that's straightforward enough. So we're going to have case and errors that as. Now I'm going to use the as function, and the as function basically I'm telling Go I want you to check the error, and if the type of the error is of type syntax error, then we will do something. And so as expects a pointer. Okay, so target must be a pointer. So what I'm going to do, I'm going to pass in error, and I'm going to pass in the address of our variable syntax error, which is of type JSON.syntax error. So if it turns out that this is actually the type of error, then what I want to do is to actually return a message. So fmt.errorf, and the message will be something like body contains badly formed JSON. And we can specify where by using at character modulus D. Okay. And we can simply specify the modulus D by saying syntax error.offset. All right, and that would tell me where the error actually is occurring. Okay, so let's move on. All right, so let's see here. Oh, okay. Yeah. Okay, another type of syntax error that can be reported is the error unexpected EOF. So let's look at that. So I will say case. We're looking for errors that is. Now I'm going to use the is because I am looking for a specific error. Not a specific type of error, but a specific error. Okay. And so I'm going to be looking for IO that error unexpected EOF. Okay. And so this error is also reported if we have syntax problems with our JSON while it's being decoded. Right? Great. So for syntax errors, there can be a syntax error of type syntax error, and there could also be an actual error unexpected EOF. Notice that this error is a value, right? That's why I'm using is. But syntax error is a type. It's an error type. Okay, and so notice it actually is a type. Okay, and that's why I use as. Okay, so if we end up getting an error unexpected E or F, then I want to also specify that there is an error. Okay, but because I'm not using as and because I'm not using syntax error, I can't really specify where the error occurred. So I'm just going to return a error. So I'm going to create a new error, and it's going to be something like badly or body contains badly formed JSON. Okay, that's the best I can do. Great. So that's our syntax errors. Now let's look at the wrong type. So let's say our struct is expecting some string, but the user's request, the client's request, is of type int. Okay, that's a problem. So we want to check, okay, for wrong types. Passed by the client. Okay, so for us that would be a case. Okay, it's a type. So errors that as. Okay, so I want to look for the type of error, specifically the unmarshalled type error. Okay, and so if it's that specific type of error, then I want to actually deal with that. Okay. Now, there are actually two instances. So let's say that the field that the user provides actually has some associated value. Okay, we could then say that that particular value is incorrect. So let's check for that. So I'm going to say if unmarshalled type error that field, okay, that field is not empty. Okay, so there is something there that the user sent. Okay, then I want to tell the client what the problem is. Okay, and so I'm going to say something like body contains incorrect JSON type for field. Okay, so I'm telling the client which field. Okay, and I will fill that in with unmarshalled type error that field. Okay, so here the client can get a good idea about which of the fields has a value of the wrong type. Okay, now if that's not the case, then we will return another error. And we will say body contains incorrect JSON type. Okay, at character modulus D. And so I will use Unmarshalled type error dot offset. Okay. So that would be how I take care of the unmarshalled type error. Okay, there are two possibilities. We have the field, we have the value, and the other case would be we don't have the value. Okay, so once that is taken care of, then we will need to look at other things, and that one in particular is when we have the empty body, right? And so, as you recall, the empty body is when we simply do not provide a JSON body. So how do we handle that? Well, that's easy enough. So let me put my comments, empty body. All right, so we're going to use errors that is because we're looking for a specific type of error, not a type, but a specific instance of an error, and that would be io.eof, right? So this is a variable, right, which is an error. Okay, and that's the reason why I'm using is. Okay. So once I know it's an EOF error, then I know I can simply return the message errors dot new something like body must not be empty. Okay. All right, so that's a good error. That's a sensible error that the client can understand, the user can understand. Now, what happens for the other type of error where the programmer messes up and we end up with an invalid unmarshalled error? So if the programmer messes up, so pass a non-nil pointer error. So if the programmer messes up, then we will stop the program. Okay, which makes sense. Okay. So again, I'm going to use the as function. I'm going to give it the address of invalid unmarshalled error. And if that happens, well, then there's no point continuing the program. So we will panic. Okay. So we'll panic with the error, and that's that. And so let's look now at the default. And so the default will simply be, we will return the error. Okay. Okay. All right, let me make sure I get my okay, I'm good. Now, if there are no errors, then of course we will need to return nil before we exit the read JSON method. All right, so let me just summarize. The read.json method will actually simply do the decoding on line 52. So that's easy. However, because there are encountered while doing the decoding, we need to actually check for those errors. So we're going to check for the syntax error. We're going to check for the unmarshalled type error. We're going to check for invalid unmarshalled error, which is a programming error. All right, and so we do a big switch. We have multiple cases. These first two for syntax errors. This one when the type that is provided is not what we expect in our struct. This one is when we have an empty body. And then this one is when we're not passing in an address to some struct where we will store the decoded values. Okay, and of course, if none of these occur, then we will simply return the error message because it's some other error that occurred. Again, if decoding went well, we will return nil. Okay, so how does this help us? Well, let's go back to our schools .go. All right, and so here, when we actually are doing the decoding, we don't need to do that anymore. All right, all we need to do is to call the read.json method. So app.read.json, we need to provide w, we need to provide r, and we need to provide dst. Remember, this has to be a pointer. So we know it's input, but we must pass the address of input. Okay, and so with that, then we should be okay. All right, so let's save this and let's open a terminal. And let's try our bad request one more time. So let's try the XML. We get body contains badly formed JSON, right, from the start. Much better. Let's try this one where we. What about this one where we have correct field, maybe correct value in terms of type, where we have a comma. That's not good. Okay. All right. Again, body contains badly formed JSON at line 17 at character 17. Good. What about this one? All right. Again, body contains incorrect JSON type. So we don't expose the underlying struct anymore, which is a good thing. What about using the wrong type? Okay. And if you recall, this would be a unmarshalled type error. Okay. And so a body contains incorrect JSON type for field name. All right. And what about the empty body? Body must not be empty. Okay. So these are much better messages compared to what we were showing previously. So there's one little change I want us to make. Let's go back to our errors.go file. Let's go to errors.go file. And if you notice that for schools, we have an error response. Let's change this to have something more specific to actually bad request. Okay, so what I'm going to do, I'm going to delete this, and I want my error message to be specific to bad error request. All right, so I'm going to say bad request response. Okay, and we're going to pass in W, we're going to pass in R, and of course we're going to pass in error. Okay, so this is the method that I want to call whenever I have a bad request. So let me go over to errors and let me implement this specific error sort of handler. So method, well, client, as a user, provided a bad request. Okay, so let me just copy and paste this to save time. All right, and let's get rid of this. So I'm gonna change the name. All right, I'm gonna have bad request response. Okay. We will accept W, we will accept R, and we also need to accept an error. Okay, great. And so what we will do is to simply we don't need to make any message because our messages have already been created for us in read.json. So all I need to do is to simply say app.error response, pass W, pass R, and I'm going to pass http dot status bad request, and then we're going to pass the error dot error. Okay, so this is the error message. So this is a specific method that we will use when we have an error. Okay, so again, if there is a bad request, so error will be returned, and then if we have an error, we will simply call bad request response with that error, which in turn will simply call error response. All right, so that looks good. All right, so let's restart our server. Okay, and everything should still work. All right, everything should still work. All right, so that's how we actually, let me just check that I have my return. Yeah, good. So this is how we actually check for bad requests. Now, in the next lesson, I want us to actually restrict the inputs. Okay, so the user providing a bad request does not take into account if the user maliciously or unmaliciously provides bad input. Maybe they provide a 5 megabyte body, okay, which is not good. So we want to be able to restrict the input that the client, that the user can provide in the JSON request. So I'll see you in that next lesson where we explore that idea.